Welcome to Module 2 of Geometry, Properties of Angles. The standards we're going to be talking about are I can understand and use angles, and I can use angle properties to solve problems. So here are some vocab that we're going to need to know. An angle consists of two different rays with the same endpoint. The rays are the sides of the angle, and the endpoint is the vertex of the angle. So these are your sides right here, the rays. The vertex is this point right here. It's the point where the two rays come together. And then the measure of the angle is the actual degree between the rays. So the bigger the measure, the bigger the angle. We have a few different types of angles. The first one is an acute, and that's between 0 and 90 degrees. And it just looks like a smaller angle. A right angle is 90 degrees. It has a little box in the corner to show that it's a right angle. Obtuse is between 90 and 180. So that is just a larger angle. And then a straight angle is 180 degrees. And that just looks like a straight line because that is 180 degrees. So draw the angle with the following measures as best as you can by hand. So 80 degrees, what I do is I look at 90 degrees. And I know this is about 90, so I know 80 is just a little bit smaller than that. 120, I think about 90, I think about 180. Let me get rid of those. I guess I could do, there we go, 90 and 180. And then it's about 60 degrees. So if I cut that in thirds, my 120 would be here. Because if this is 30, 30, 30, that would give me 120. 20 degrees, half of 90 is 45, half of that is 22.5, so that's pretty close, so a little bit less. So if I just get rid of that, and there you go. So that's kind of how I estimate angles and how I measure angles. There's a few different ways angles are labeled. The first one is, come on, there we go. Labeling it in three different points, kind of connecting the dots. So if I start with K, I go down to J and H. So angle K, J, H. You could do HJK and go the other way. Angle HJK. A third way is if the angle is all by itself. So there's only one angle with that vertex. And maybe I need to get rid of all these lines so you can see it a little bit better. So if there's only one angle with vertex J, I could also say angle J. These you can always do, this one only sometimes. So here there's a few different ways we could name this because I could start at P. The thing to count though is B has to be in the middle. So I can't say A, P, A, B, W, C. You only do 3 letters and the vertex has to be in the middle. So P, A, W, A, B, C. I could say angle B because it's all by itself. C, B, P. So those are just a few different ways naming angles. You just take one point on each ray and the vertex. If there is a letter or a number in the angle, you can say angle X or angle 1. So we can name it that way if there is a number or letter in the angle. Highlight angle B. Well, if I look at angle B, there's lots of angles that could be angle B. Could be this one, could be this one, could be this one. There's lots of them. So we don't really know which one it could be. So we can't name it as angle B. Now highlight ABF. Start at A, go to B, and then go to F. That would be your angle. Obtuse, acute, obtuse, right, or straight. Well, if we look, this is a 90-degree angle, so it's more than 90 degrees, but it's not a right angle or a straight angle. So it's not acute, right, or straight, so it has to be obtuse. A straight would be a straight line. A right angle would have to be a box in the corner. So there's a few things that would have to be true for it to be the other three. Alright, so highlight the following angles. CED. Start at C, go to E, go to D. GBC. ABF. Angle 3. So angle 3 is way over here. So now I need to, 3's in the corner, I label the rays that are connecting angle 3. So this would be my angle 3. Now we are going to name an angle that is already bolded. So for this one, this B is in the middle, so it always has to be in the middle. It says the vertex. I can start with A, B, G. Or I could do G, B, A. Either way, B always has to be in the middle. Alright, see if you guys can write this one down. This one has many different ways you can name this. I named it these two different ways. MCN. You could do QCB. As long as C is in the middle and B or N is on one side of C, and then M and Q are on the other side of C. So there's a lot of different ways that you could name that angle. Alright, so now we're going to talk about solving some angles. So congruent angles, we already talked about congruent segments, and it's going to be the very same thing with congruent angles. Angle bisectors is just a ray that divides the angle into congruent angles. So let's bisect this one. So I'm going to put a ray down the middle with a new point S. That is going to be bisect, but we have to put some tick marks. And we're going to do different tick marks than we do for segments. So we do little arcs in the angles, and that shows us that those two angles are going to be congruent. The name of this is going to be ray ES. You have to start with E because that is the vertex, that is the end point of the ray, and it goes through S. So a little bit of segment there. This one, same thing as segments. Part plus part equals the whole. So same thing for your angle addition postulate. You take one angle, you add it to another angle, and you get the whole angle. So our first angle is going to be this one. It's going to be angle RSP. And then this one, angle PST. And then that's going to equal the whole angle. So it's going to be angle RST. So part plus part equals the whole. Alright, so we have a few different problems here. Given that the measure of angle GFJ, so first I have to figure out what GFJ is. GFJ, so that's the whole angle. So my whole angle is 155 degrees. So this is part plus part equals the whole because I'm given the whole thing. So 4x plus 4 plus 4x minus 1 equals 155 degrees. And then we can solve. All right, so we got 19 for x, and then it says to find the measure of GFH. So GFH is this angle right here. The measure of angle H equals 4 times 19 plus 4. When we're talking about the degree of an angle, that's when the m comes in. When we're talking about the actual angle, so when we talked about equals versus congruent, the measure comes when we're talking about equal. The measure goes away when we're talking about the angle, and that's when the congruent sign comes in. So this is 80 degrees if you plugged it in. Alright, so now a different type of problem. In the diagram, WY bisects. Well, bisect means to cut in half. So if you see in the picture, we have the angle tick marks that already show that your two angles are congruent. ZWY is 2x plus 19, so this is 2x plus 19. And then YWZ is 7x minus 11. 7x minus 11. So, those two, if you see that they're the tick marks in there, you know that they're equal. So this is part equals part. So 7x minus 11 equals 2x plus 19. And then we can solve, which I will do, you can do on your own as well. Alright, I get x equals 6. It says to find the measure of XWZ. XWZ, that's the whole angle. So what I could do is I could plug it into half of it and then just times it by 2. So let's do 2 times 6 plus 19, and I get 31. So if this is 31, then this one is 31. So the measure of angle XWZ equals 62. Alright, we're not going to solve this one, but we are going to set it up. So this one doesn't tell you anything except what to find. So if we look at this picture, it must tell us something. Well, there's no tick marks to show that they're equal, and they don't even look the same for the angles. We also see, though, this little symbol right here. That is a right angle symbol. So that shows that the total is 90 degrees. So this is the part plus part equals the whole. X minus 4 plus 3x plus 2 equals my 90. Part plus part equals the whole. So pay attention to those tick marks in there, and they will tell you if you know a total or if you know that they are going to be congruent. Alright, some more vocab. Complementary angles, supplementary angles. We are going to be using that a ton. Complementary angles are two angles whose sum is 90 degrees. They add up to 90 degrees. So you could have them together. So actually the last problem we had. So if you have a little right angle symbol in there. Or you could just have two angles. This could be 50. And this could be 40 because they add up to 90 degrees. Supplementary is two angles whose sum is 180. So there's a 180 degree angle. Make it half. Then you could also have two angles here. One could be 120. One could be 60. So that also works to be supplementary. The first pair here, these two, are adjacent. Adjacent means right next to. So they share a vertex and they share a side. So these two angles, this angle and this angle, are adjacent because they share this vertex and they share a side. So same with this angle, these two angles and these two angles, they are also adjacent. A linear pair are adjacent supplementary angles. So adjacent supplementary angles look like this. A linear pair, the word line is in there, so it needs to form a line. So there is my linear pair. Vertical angles, angles that share a common vertex and are across from each other. So if I make like an X, this angle and this angle are vertical. Also, this angle and this angle are also vertical if you have a complete X. So those are vertical angles, and we will learn later on that the vertical angles are congruent, and that's just a theorem that we can learn. So we could fill this chart out. Let's do one of them together, and then you can fill out the rest on your own. A complement, remember, it adds up to 90. So what you're going to do is you're going to take 90 and you're going to subtract 57. And I get 33. So those two, 57 and 33, add up to 90. For the supplement, you're going to take 180 and subtract 57 to get 123. Because 57 plus 123 gives you 180. And that's what a supplement is. So see if you can figure out the rest, and then we'll talk about them after. Okay, so if you see, 165 doesn't have a complement and neither does 101. The reason being, these two angles are above 90 degrees. So this plus a 90 degree plus something doesn't give you ever 90. It's already above 90. In this class, we're never going to do negative angles, so it doesn't work. So you only have a supplement in this case. 6 also has both a complement and a supplement of 84 and 174. Alright, so we have 2 problems left. I would like you to see if you can set up the first one and solve it, and then we will talk about it. Okay, the most challenging part is to realize that this is a straight angle, so the total is 180 degrees. So that's probably where, if you did get stuck, that's where you probably did. Part plus part equals the whole, so if you knew the whole was 180, then you can set up part plus part equals the whole. After you get 25, then you can plug it both and each side, because that's what it said up here, is that's what the 2 angles you wanted to find. And you would get 83 and 97. The 2 angles form a linear pair. The measure of one angle is 4 times the measure of another. So first you have to figure out what a linear pair is. A linear pair, if you go back to the first part of this video, we talked was looking like this. It's 2 angles forming a line. The measure of one angle is 4 times the measure of the other. Well, when you don't know what an angle is, you can put it as x, especially if you say the other angle is 4 times as much. So I can say 4x and x. And then it says find the measure of each angle. Well, if this is a line, that means the total is 180. So part plus part equals the whole. So 5x equals 180. So that gives me divided by 5, and I get 36. So if I plug it back in, this side is going to be 36, because it says find the measure of each angle, and then I do 36 times 4 to get 144 to get the measure of each angle. So that is all about angles.